Hello everyone, this is Guy and Helmers from Genome Studios with another O3DE intensive. Now this one's going to be fairly intense because we're going to be covering rotation kind of in general all over the place. Getting a nice rotating camera, uh, rotating our character, and all of the complexities therein. So I'm going to get started by just kind of setting up the project for camera input and camera movement. So first we're going to open our input bindings, and we only have our forward, back, left, right, and from a previous intensive, jump. So what I'm going to do is I'm going to add two more, and they are going to be um, camera pitch and camera yaw, let's say. And camera pitch will be input event map, not gamepad, but mouse. And then mouse delta pitch is Y. Pitch is look up, look down. And yaw is spin in place. Neither of these do a barrel roll, unfortunately. But we'll get that yaw going now. Same idea. Mouse delta X this time. So that we're rotating along horizontal. And then one thing I wanted to add is that the event binding multiplier is set to 1. And in a lot of cases that's good. But with these mouse deltas, they give, I think it's pixel values or some sort of very small but lots value. So when you get this, the values you're going to get is kind of enormous. And likewise, for mouse being relative to camera movement, we actually want to invert the inputs. You can do this in processing, but it kind of makes it easy to just do it here. Now, like I was saying, the values are really high, so I was also going to just, for tutorial sake, drop it down to minus 0.1. Which will still probably give quite large values. I think in my project I ended up being to 0.02, but we'll just do this for now. I think that's all we need for inputs. Then, I mean, this might be obvious, but we're going to go into our global camera events. And in this case, this was made during the physics and tick bus tutorial, previous O3D intensive. And all it had was a means to just call out to the global world that to set a camera follow target. Now, this is all going to be feasible in single player, but if you start getting to complicated multiplayer things, you don't want to necessarily have all of your camera events handled globally. But for now, for the simplicity of this tutorial, we're going to use our old global camera events that already existed to piggyback with our events. And this one will be update camera axis, let's say. It's not going to take a return value, and we're going to just give it a vector 2, which will be our pitch and our yaw. I guess it's yaw and pitch. You don't want to yaw and pitch. You need to have a solid name, or else it'll give you warnings or errors. Update camera axis. And I hope you don't mind, I'll be looking at my little thing. Okay. And then we want to go find our mock camera rig that we also made during that tutorial. All this has is a camera follower, and it's an owner of the local camera. I'm going to bring it out of my arbitrary assets folder. Oops. Here we go. So that can be part of the fun. And we got our mock camera rig. So I'm going to get rid of the mock part because it's now becoming a real camera rig. We've got our camera target follower. And we're going to just use that to be doing all of our camera rig logic. Again, you could call it camera rig or company camera rig or whatever you want to call it. But what we're going to do here is we're going to create a child entity for the camera rig, and we're going to call it vertical pivot. So this is our pitch. and we want to reset the position transform values so that it mimics our camera rig. So camera rig is 0, 0, 0, 0, 0, vertical pivot inside is 0, 0, 0, 0, 0, and then we're going to take our camera, we're going to put that in the vertical pivot, and then we're going to, oh, it kept its numbers, good. And the only thing that we had was that the camera is -3 behind and 2 units up so that we can see above our character. Now, what you'll see is that this vertical pivot, we're going to be rotating the X. So let's say, 25 degrees. Now we're looking from below to up, or -20 degrees. Now we're looking up to down. So that is our pivot's purpose. And then our rig will be on the Z-axis, and we'll go anywhere from 360 degrees. So the 90 degrees is looking from the side. 40 degrees is in an angle. And this is how we're going to essentially pilot our camera rig. So one last addition is that on our camera target follower, we want to add a entity and call it pivot, and we're going to call it initial value source from component here, and save, which should allow us to now have our pivot here. And we're going to give it our vertical pivot there. So we've got our rig, pivot, camera. The rig has the target follower. I hope you followed our other tutorials. What they do is, in previous ones, the learning events through physics character, one that just is going to be released not too soon from now, regarding updating the character movement. We're using a set of patterns that, we're now reliant on for these tutorials, which is there's what's called a possession pattern, which is we have our player controller, and then we have a possessee, a target unit. And what this does is that it gives you a thing that controls the brain and a thing that controls the body. And what you drive is a connection from the brain to the body, which allows you to then start communicating and handling things on both sides. So for the for the setup here, we'll get to why we're doing it. We're going to go on our unit and we're going to add tag, gameplay tag here. That's a good start. It's an important thing. If we want to be adding tags to our entities, it needs to have a tag component on it. Otherwise, your add tag calls will be unheard and add no tags to anything. All right, real quick, that should give us everything, rig events and inputs. Let's get some camera rotation logic. So I'm going to click save here real quick, and we'll get into some of this. So on our player controller, we updated that global camera events, and so it marked it dirty here, and that's fine. We can just save that. Nothing's changed. As per our last lesson on movement improvements, we are setting movement and then passing it to our target unit. And very similarly, we're going to be connecting to our camera inputs and passing our camera inputs to a camera. So here we go. I just duplicated our input handlers here. We're just going to tie it back to the on graph start. Good, but we need to change these names to what we named, camera pitch and camera yaw. So camera pitch is our forward back, and camera yaw is our horizontal left to right. And then we've got our pressed, held, release. Usually pressed doesn't really matter all too much, so usually what I do is I go from held. But just before that, we have our movement inputs. I'm just up here. I'm going to just copy or duplicate it. Now we've got movement input copy. I'm going to say move camera input. Now we have 2. So we're going to go here. We're going to go, oops. We can just probably copy all this. Copy V here. and then just replace all of these references to move input instead to move camera input. Camera, move camera, camera, move camera, move camera. And now we go set X is our horizontal. So that's our yaw. Pressed and, or sorry, not pressed, held. And we're giving it how much the delta of our camera is to how much we're setting the X. Then we're going to be setting the X on release to 0. Same thing, we're going to go with held. We're going to take the value for Y, and that's our pitch. And then we're going to do what we just did, which was camera, what is our event called? Update camera axis, and we're going to send that. So we've got our yaw and pitch. We can promote to, or convert to reference. It's going to take our movement input, but we want our move camera input has been set over here. And then we can do the same thing. Update our camera as soon as we know that the axis is being changed. And while we're here on the player controller, I'm just going to, we just have a set camera follow target to our target unit. We're also going to add tag to that same target unit, and we're going to call it player. So as you do with a little bit more system work, you'd have a possession function, and you'd be able to do special logic that says, hey, we're going to make sure that the player controller, the target unit, our camera inputs, and everything are all aligned, and no one can talk to anyone else's stuff. Now, I'm not doing that. I'm just kind of doing some manual stuff, setting the camera to follow our target. The camera has no means to verify that the target is the player. We're just doing it in player controller, so that makes sense. And similarly, our unit here doesn't know who's telling it what to do. We're just giving it input. In the case of an AI, the input is AI input, and in the case of a player, it's player input. So in this case, we're now saying, hey, target unit, you may be able to tell yourself, or like identify that you yourself are a player unit. And it's because this unit in particular is now being owned by our controller, our brain. So we're now updating the camera axis. We've done a little bit of prerequisite stuff there for our player. And let's go to our camera target follower. So here we're going to get our camera, move, camera, I can't remember that, something axis, update camera axis, and we're going to receive this one this time. And very similarly to everything, we're going to now process it right off the bat. Let me see. We've got cam input events. We registered for that. Sending our player input via the update camera axis. All right. So what we want to do is, let's see, additive to pitch and yaw. All right. So we're in our camera. We've got our pivot and we've got our self. We're following our target. So now we want to have some local variables. So we're going to go call one pitch, just lowercase. We're going to call one yaw. We're going to call pitch max angle. Oops. That is the search, not the name. Pitch max angle. I'm going to duplicate this pitch max angle, call it pitch min angle. These are just some things that I'm going to show you down the line so that we don't, the camera doesn't just start flying everywhere and disorienting us beyond measure. Let's see from my thing, min angle is minus 40 degrees and max angle is 30. We want to add camera rot speed. Sorry, number, camera rotate speed. And it was rads per second, so it didn't have to be very high. We can give it a 5 for now. What else do we have? Rotate speed, min thing, additive pitch, and yaw. Okay. So now that we have our yaw and our pitch, we can extract properties. We've got our X and our Y here. So what we're going to do is we're going to add space, oops, add space bracket, there we go. Our X value is our, okay, we're going to just do this pitch. So we're going to add Y to our pitch. And then we're going to add to our yaw. And then, just as some simple, some shorthand, instead of getting pitch, adding number to pitch number, and then setting pitch, we're going to do that all here. So now we reference pitch, add our extra pitch value, and then set it all in the same one. And then same thing with yaw. We've set the yaw. Good, additively. So what's happening is as our camera says the mouse has moved left by 10 pixels, it's going to add move left by 10 pixels to our yaw from what it was before, because our yaw may be 95 degrees right now, and so then we're going to add 10 pixels to the 95 degrees as it is. Or if you go backwards, you know, minus 30 from 95 degrees, then it'll reduce it down the degrees. So that's good how we've got our camera axis here. And then let's actually try to use it. So here in the original camera and tick order tutorial, I did a really simple thing of just saying we've got our follow target that we got set from the set camera follow target event. But what I did is I set our world transform, i.e. the rig, the camera rig, to just be the transform of our follow target. But the thing about transform is that it's both position and rotation. So unfortunately, when we do this, the camera both moves and turns, or the rig moves and turns without us wanting to. So I'm going to actually remove this. Oops. And we want to go, well, let's just get rid of all this. Get world translation, and that's only position, and that we're getting from our camera rig. And then we're setting world translation, oh, sorry, we're getting it from our follow target. So where is our follow target? We're going to put our rig exactly on the same spot. But now, moving out from here, we can then begin to calculate what the rotation is. So we're going to go set world rotation for ourself, and we're going to actually duplicate this because we are going to also be affecting our pivot. I had told you we're going to be changing our pivot's X value to look up and down, and we're going to change our rig's Z value to spin around our exactly held in place position of our character. So let me quickly look at my references here again. Set yaw to rig, clan, blah, blah. Okay, so then what we're doing is we're going to go radians to degrees to radians, good. We're going to do 2 of these. Again, one for our pitch and one for our yaw. But this time we're not storing this value, we're just converting it so that we can do it. As you can see, our world rotation actually takes radians, but the pitch and yaw that I was talking about was in degrees. Degrees to radians, we've got pitch, we've got cell rotation, so we can go create from values. Oops. Oh, no, it's not from values. We're going to go vector 3. And we're going to go, this will be for our yaw, actually. Our pivot is our pitch. So we're going to go our yaw on this Z, and then we're going to give that to our world rotation for our rig. And then we're going to go clamp. Is it functions? Okay, good. And we're going to take our pitch, and we're going to, where is it? Minimum pitch min angle and pitch max angle. And then we can apply this from values to our pivot. So in the case of what we're doing, let's we'll worry about our yaw, and then we'll worry about our pitch. And then this time we're putting our pitch onto the X angle, and we're setting the world rotation of our pivot here. Hoo-wee, okay. Let's see if this works. Now the clamp is just so that your camera doesn't go too far down or too far up, because if you then flip over your character, you're now inverted. You're looking, the ceiling is the ground and the ground is the ceiling. So this clamp really helps with that. This is on tick. We're repositioning our character. We're getting our factored rotational things, and we're setting our rotation of our rig. And this is all based off of our camera input. And let's see how this goes. We've got our rig here. It's looking for the pivot. It was in the unused variables, and then it moved. And so that broke our reference here. So it's worth double checking that. We've got our vertical pivot. It doesn't matter. We've got our camera. It doesn't matter. We've got our player controller. I didn't expose anything to that. We've got our unit. I didn't expose anything to that. Let's see if our camera works. Okay, so the pitch is working, but the yaw isn't working. Move camera input. X and 0, camera yaw, camera pitch. Is it actually called camera yaw? Did mouse delta X, mouse delta Y? Okay, so just for some real quick processing, pitch, yaw, yaw, X is whatever. So we're going to go print value yaw. Our yaw is save. Oh, my keyboard stops being able to save sometimes. Let's see here what our yaw is. Okay, our yaw is changing. Maybe I missed something here. Get world translation, set world translation, yes. Degrees to radians, we have pitch. Degrees to radians, we have yaw. We're clamping from, so we're taking our yaw, giving it to the z-axis of our three-dimensional, our vector 3, and we're setting the world rotation of our camera here. I'm going to go here, oops, print, setting rig rotation to save. Oh, my keyboard save isn't working. And I put that other one, okay, I got rid of it, okay. So let's clear this. Okay, so we are setting the Z of our camera rig. And now I'm wondering if set world rotation. To our Z. And that is our world rotation Z. All right, well, just for some real simple decoupling, I'm going to go, we're going to make another entity called swivel. And now we will set our swivel world rotation. No. I see. We want to set local rotation on our swivel. And we want to set local rotation of our pivot. Let me see here. File, save. We'll go here. Now we've got our vertical and our swivel. We're going to have to do a little bit of swivel. And we're going to reset the transforms here. And we're going to give our vertical pivot to that. So now we've got swivel 0, 0, 0, vertical pivot 0, 0, 0. We could call this horizontal swivel. And now we've got our camera rig with our pivot and our swivel set. This is all the same. We're feeding our swivel and our pivot separately. This is just to decouple our set world translation that's happening. Let's see if this works any better. So we've got our turn and we've got our pivot, and it's working great. Good for that. Thanks for following along for this little problem-solving little thing. And here we go. We've got our camera turning and pivoting all the way around. It's on the character that we need. But now let's go this way. Oh, wait, no, let's go this way. I'm just clicking forward and I'm clicking back. Oh, surprise! Turns out our inputs are actually statically forward, back, left, and right as it goes by the cardinal directions of the game world. So no matter how I change my direction, the inputs go crazy. And as you can see here, our character just rotates because they touched the surface of the thing rather than anything meaningful. And as you can see, our AI Guardian does the exact same thing. It's moving up, down, left, right, completely regardless of its rotation. So I have anticipated this particular thing, which is why we'll step to our next part of the lesson, which is relative camera movement logic. And I added the player tags already, and I've added the player controller setting the tags, as we can see again here on the player controller. I am telling the target unit that their tag is player, and we made our unit carry a tag. So all your units would want a tag component just out of necessity, so that no matter if your unit is a player or if it's someone, in a different room that you puzzle solve, possess them like a ghost and stuff, they need a tag so that the game world can know that, okay, while I'm running, I'm the player. Like while I'm possessed by the player ghost, I'm the player, or something. You know, these are logical things you may need to factor. And so we are going to factor it here in our unit with our movement. So what's happening is our input movement is based off of our controller, which is forward, back, left, and right. There's nothing relative to what direction our head was pointed or what direction we were holding our controller when we pressed forward, back, left, and right. It's just saying move what is considered forward in the whole world of things, and et cetera, et cetera. So what we actually need to do is now that we have our input from whatever controller we may have, we need to change it a little bit. So this was just a print function to just report what the movement axis was. So I'm going to just delete these. Now what we want to do is we want to go has tag. And so with this, we can say, hey, are you the player? And if we are the player, we can do something. And if we aren't the player, we can do something. So earlier in the previous tutorial, we made a variable called desired direction. We're going to use that in a little bit. But for now, we're going to make a vector3. Oh, come on. There we go. I'm going to just call it move magnitude, move mag. And basically, this move mag, set move mag, is going to be different whether you're a player or you are a unit. So what we can do is we can just go, so false, we're not the player, this is the AI. We can go from values, vector3, and our move magnitude is forward, back is y. So we could just for the sake of it, go here, and left and right is x because z is up and down, and set our movement magnitude here from that. So what this is we're going to group it, go by input, and we're going to go AI input. So this is not relative to a camera, it's relative to data, which is just the AI knows that if it needs to go back and to the left, it just will. And that's great. But then we want to then do something a little bit different here. We're going to now make our, I'll do it red, player input. So we're still setting the movement magnitude, but now we're going to do a little bit of math. So because we are the unit, we are going to get active camera. And from this, we're going to get entity forward with a scale of 1. And we're going to get entity right with a scale of 1. And then we're going to do some math around this. So let me just see what my steps were. Forward and right. Oh, we're going to extract properties and extract properties. So then we're going to create our forward from x and y. And we're going to create our right from x and y, which means that height-wise, there's no difference we're just looking horizontally from where we are and where our camera is looking horizontally. So now we have normalize for a vector 3. We're going to duplicate this. So now it's turning it back into just a movement direction, +1, -1 kind of thing. Oh, we can do this one at a time. And nice, okay. So now, just because it's quite out of the way, I'm going to move this over, and while we get active camera, we're also going to get local move axis. Right, that's the one we set? Yes. Okay, just for ease. So then it says what we want to do is multiply forward by right. So then we go multiply by number, vector 3. Gonna duplicate that over here to our right. And our multipliers are our input, let's see, X for right, Y for forward, and that gives us, oh nice, we just need to add our two values together, our forward and our right, and set our movement magnitude. I'm doing this for visibility. You can always do a reference right here to set the movement magnitude at the end. But this final thing is to get our changed directions. So now that we have our camera, we're basically converting our axis input to twist and spin to meet our active camera, so that local move forward becomes active camera forward, and local move right becomes active camera right, and well, if you start cranking in some diagonal direction, it starts processing it into some numbers that you need. So we've got our movement magnitude. And so when we come down to getting our desired speed, we're going to put our movement mag. So our movement mag says we've now made some interesting direction, or in the case of the AI, we're just taking the exact direction that we're doing. And now we're applying, our movement speed, and we're changing how much per frame we're doing, which makes this frame rate independent. And then we're applying linear impulse. So I'm really hoping that we've got our movement magnitude from this correctly. So I'm going to save. Oh, one validation issue. Oops, I see. I didn't connect this from values. Make sure that the line is correct. So getting camera, getting local movement axis, then we're processing all of the forwards. So forward, take away the Z from the forward, create a new value from it, normalize that value, and then multiply it by our forward inputs. And same thing, get the right values, extract the Z, which is height, normalize that, and multiply that by our left-right axis. And then we're adding those together, and that makes our movement magnitude. So let's see. Now if I turn this way and I click forward, I do in fact go forward. And if I hold forward while turning, my character, with physics, moves in the direction that my camera is looking. See, I totally flip around, and I'm just holding forward. If I click left, now I'm moving left. If I stop and I go right, I'm moving right. But if we look, our AI is still doing their crazy relative movement, or cardinal locked axial movement. And we're both able to do it. Now, as you see, when my character is spinning, oh, No, never mind. Oh, sometimes. Yeah. So begins the need for our character to move, or to rotate now. So that's great. Now we can move and all that fun stuff. Now our character is just spinning and causing a lot of weird forces and things. So now we need to actually update our character movement. We've got our camera axis is changing. We've got our player controller setting the player tag. We've got our unit moving relative to either no camera or some camera. And now we need to kind of process all of this. So we got our local move axis. Oh, we don't need this anymore. We don't have our desired direction anymore. We want to go, is our move magnitude 0? And if it isn't, we want to set our desired direction to our move magnitude. So the reason for this is that if you let go, if you let go of inputs and your move magnitude becomes 0, effectively we can't derive a direction for your character to look in. So whenever you're looking in a direction, i.e. because you're cranking in that direction, we simply store that as long as it's relative, so that if we don't have movement, we still know what the last direction was we were looking in. So we're checking our move mag, we have it. We're setting our desired direction if we do have magnitude to use. And then we can kind of just go back to setting our getting our speed and giving it with the move magnitude, and then applying that force to our character's physics. So save. Now that we have, let me see this here. We want our intended direction, which is basically our move magnitude, but it just it disables changing if it's not correct. We want to get that. Get desired direction. And we want to get unit forward. And we're in the unit, so get forward. We need to transform. Well, I'm going to just go get entity forward, which is the self. Our scale is by 1. And here we go. So we've got our intended direction, and we've got our current forward as it stands. And so now we're going to identify what the difference is between them. So we're going to use a dot product. Oops, that's color. Make sure it's the right dot, which is a vector 3. And we're going to do, let's see, forward over direction. So we've got our unit forward over our direction. Oops, over our direction. Then we're going to do a multiply. Oops, multiply. We don't need our dot. We need our multiply both lengths. Okay, so we need get length, get size, vector 3, Um, where is it? Is normal length. Here we go. Length. So we want two of these. One is our desired direction, and one is our entity forward. And we want to multiply them together, multiply both lengths. So we can go from one length to the other and then out. We're just multiplying them, so it doesn't matter which one over which. We're going to bring our dot down here. And we're going to divide our dot over our lengths to get us a rotation magnitude. And we want an A cosine right here from our result. Okay, so then this is our turn magnitude after this A cosine. But next, the problem is the way that this math works, and I'm not a mathematician, is that we basically are finding the orbit axis, the poles. And in doing so, this value here is just how much we need to turn. And it's how much we need to turn on that pole with no discernible direction. It's not turn left, turn right. It's just the turn amount will be 11. It doesn't say what axis. It doesn't say anything. So now we need to then start doing a few checks. So what I'm getting is cross of forward over dot, get the cross product of vector 3, and we're going with entity forward over the dot result. What am I doing? Get entity forward. This is not correct. Forward over dot. We want to extract properties. I'm just going to quickly so then we want to compare is greater than or equals to 0. Then we have here, I'm just going to put a group positive rotation. And I'm going to duplicate this and go negative rotation. And bear with me for just a second. I need to actually close our editor. Let's save. Close the project. Save. We've got our tutorial here, but that's not what we're going for. I'm actually going to pull up my project. Thanks for coming along for this intensive. I appreciate your your attention. We're going to just verify. I tried to simplify what I was seeing visually into text, and I missed a bit of a detail here. This should hopefully go quickly here. I know exactly what I'm looking for. World streaming, just because that's the last level I was in. Clear our warnings. We're going to go to Tools, Script Canvas. We're going to go to My Mover. And we're going to look at exactly that calculation way over here in our work. So what did this get? A is our entity forward, and B is our direction. Okay. Okay, good. I don't need to save. I don't need to save. Let's get back to the intensives. That's simple. Yeah, the cross product of uh, from where we're looking to where the direction is, are we positive, which is a cross direction of right, I guess, or are we negative, which is left? Um, and that's how we're determining that. So let's pull this back up, go to unit, and we have this here. Okay, so then we want our get direction, and we're going out, going into that, extract properties greater than or equals to positive or negative rotation. So then we need our, wait, did I make one? I think I did. No, I did not. Let's do that now. Rotation speed. And let's do that from component. I'll set it to, let's go 10 again, just so that those two values are similar. Save, and then we can go, it's true, so then we can go multiply by, let me quickly refer to this. Had to move set final road speed times 1. Okay, so then we're going. Okay, we have our magnitude, and we're going to go multiply, and we're going to multiply it by our rotation speed. So now we have rotate by this intensity, and we still don't know positive or negative. So then we're going to go, if true, it's positive, so then that's fine. But then if false, we're going to go, what is it, times -1? Here we go. So then we can go here. What would be better? Do I do my multiply before? Okay, let's do that. We're going to multiply, get our speed. Now we're going to know how to apply our speed via our rotations. So we're going to go here. Our negative rotation is going to be here. Our positive rotation's here. And then I think multiply by speed, delta, then angular velocity. We can do, oops. We can still go from here, and we've got our rotation speed. Now we got to go apply by our way back here, time delta time. Pew. So now we have a delta rotate speed. And now, again, we can, oops, I don't want these. We've got our greater than equal then. So then we can go set angular velocity. I'm going to duplicate this because we've got our positive and our negative here. And we've got our greater than or equal, so true is going to go this way, false is going to go this way. And we have these velocities, and they are on the z-axis. So now we need to create, from values, our z here. going to duplicate here, and we're going to create it from our inverse of our speeds. And then we can interrupt this. Interrupt that, go here, go here, go here. Angular velocity. Let's see. Negative rotation. Save. Oh my, I hope this works. It's been a bit here. Okay, so camera movement is working. Let's go to our unit. Let's mess with our rotation speed. I'm gonna go for 100 now. Let's go save. There we go. And our character rotates until they kind of hit that point. And then let's go that way, and they rotate and rotate and rotate until they hit that point. So let's get a little bit more responsive. We can go here and do, I think maybe like 400 might be good. Oh. It's moving based off of our Guardian's rotation. What are we doing here? I think I might have used Guardian as a reference somewhere that I probably shouldn't have. Get active camera, get entity forward of the camera, get entity right of the camera. Oops. That's a mistake for sure to make. Turn this way, go forward, turn that way, turn this way. We're going in the... Hey everyone, so I just cut off the last video because, well, after everything, I had everything set up pretty well, but I had to do a great deal of problem solving, and I wanted to spare you guys probably the 40 minutes that I spent. So just follow what everything was saying beforehand. You know, we found that nice little bug with improperly referenced direction to get our camera entity right as well as our entity forward. But then I'm going to quickly glance over what I had changed to some of these. I made sure to get my direction, get my forward, do my dot, do my lengths and the multiply. The divide was correct. And then I did a bunch of kind of forces, you know, delta time and speed and things like that before checking, setting the final positive and negative rotations. So what I did is, that was a bug fisking thing, is you go from your division of your dot and your the culmination of your multiplies, and this gives you a magnitude that gets fed into your arc cosine. I found out. I like ACOS. So I'm just doing the left-right check right immediately. So then what I do at the very end is that after I decide, okay, I'm either 0 or I'm less than 0, above or less than, I set a kind of a variable that's just holding the data right now. So it's called final rotation magnitude, and it's either going to be our arc cosine as it is, or if we want a negative, we're going to just invert it. And this is determined because we used our cross product to identify if it's saying, hey, we should look left or we should look right to determine that. So positive, I guess, is look right, negative is look left, yeah, kind of thing. And then I take my final rotation magnitude and I multiply it by the rotation speed. And I think these are where it was kind of falling apart. And I take my my delta time and multiply our magnitude and speed combination by that. And then I feed it as I would into this from values with set angular velocity. So then if you go and you get rid of all the comments, our character rotates freely, like butter, like I wanted to show you like maybe an hour and a half ago when I started problem solving this. You'll notice a bunch of warnings here, and it's actually coming from our NPC. In fact, the direction value it was giving actually gives some sort of improper math there. So that might need some problem solving down the line. Just catch if it's going above and beyond for some reason. Yeah, there you go, above and beyond right there again. But it's not to do with me. It's just because our NPC is running around messing up my beautiful presentation. But that's a different issue. I can go AI controller will remove its reference. Does this work? Yeah. Beautiful. Rotate in your direction. Rotate your camera. Pitch and yaw. Oh, look, our clip is... well, our clamp isn't working, but that's okay. Move left, move right, move up and down. And there we go. Actually, I'm going to quickly look at the clamp because I think I know what's the problem. Go into our camera, target follower, and I clamp. Clamp our pitch. Oh, oops. We probably want to clamp before we do it. I guess we'll do our yaw first. We'll clamp these degrees to radians. We'll take pitch, convert for reference, pitch, got our rotation, pitch min, pitch max, out, convert to value. Here we go, degrees to radians. Things, and we're putting it on our X here. Yep. Don't want to mess. Let's see. And here we go. Our clamp actually works. And you'll notice that if you keep going up and keep going up and keep going up, and then you try and go down, it stacks. So what we actually want to do is clamp our pitch. Oops. And then draw from our pitch. So then here we go. Right when you hit your pitch cap and you start reducing, it instantly responds. Pitch cap, it instantly responds. Left goes 360, 360, 360. Right goes 360, 360, 360. I can move forwards, backwards. I can move backwards while looking forwards, backwards. I can spin in all sorts of directions based off of just hitting WSD, DS, DSS, SDSS, DSS. And there you go. You've got rotation, character movement, the character points in the direction you want, and you got to problem solve with me a little bit. I got to problem solve an hour and a half longer, and then we got to problem solve a little bit. So thanks so much for coming. I hope this sets you up with some really strong character movement and camera movement. This should cover everything now. We've got left, right, up, down, camera changing, camera angles, and you can build off of this to make all sorts of characters. One thing I do advise is try to use these complicated turning maths using dot and cross and all those things, because it's very easy to want to use LookAt, create LookAt, but this doesn't work like you think it does. almost in all cases. Um, it basically, from what I've understood exploring the use of it, is that it from and to are positions, and then the lookat that it creates based off of the axis. So in this case, plus 2 or 2 is up. You can see by holding here, 2 is y plus value. So with this orientation, it gives you a rotation from position to direction, but the rotation it gives is based off of cardinal axes. So this y plus. So it's not actually a from rotation and a to rotation. It's just a direction, and then they go, well, from cardinal forward to the direction, it's this. So a lot of times people think the from would be my current rotation, and the to is my destination rotation, and then this is just up axis or forward axis. Well, I mean, if this were up axis, we'd want to do z plus, right? And so then if you try z plus with this, oh wow, the numbers are awful. And that's because this from and to are not rotations, they're positions. And the lookat takes positions and goes from north, like an AI, to the destination that we're looking at. So don't use that. Use good maths. And I hope that this gives you at least a precursor to start investigating how you would then do more advanced turning if you need other things. But of course, this can all be modified. You don't have to use camera forward. You can use all sorts of different anchoring positions. You could ignore the camera rotation, and you can do movements and rotations based off of the trajectory you want to go, just like how we're seeing with our NPC. Oh, right, I disabled him. With our NPC is that in this case, the direction that they're pushing is the direction the character moves. So if they're moving on a pointed direction from a mouse click, it will move in that direction as intended, so long as you're giving it that direction input. And of course, if you follow my AI tutorial, this AI is still using the physics controller and a default unit. And that is why you can assume that there's going to always be an input direction that they can adhere to turning towards. Because in the same way that the AI sends its intention to move and rotate and move this way and move that way, it's the exact same as doing WASD input. They're just calculating it differently. So yeah, I hope this covers absolutely everything when it comes to rotations, rotating your character, rotating your movement, rotating your mouse up and down, rotating your, AI-controlled unit, and everything in between. So let me know how this was, how you're doing, and till the next time. Thanks so much. Bye, you guys.